Today we are going to deal with, as you can see, the topic concentration terms. Now this topic is really important in various chapters, like if you have it in solutions or mole concept or stoichiometry or even in acid bases and salts. There are many different chapters wherein concentration terms are used. Okay. Now firstly, when I talk about concentration terms, what is concentration? Concentration is when you have an amount of substance dissolved or mixed with the other substance, you want to know how much of that substance is added to the whole solution. Or you can say you have a mixture, in that mixture how much amount of solute is present. Now concentration can be calculated by involving different terms. Okay. Now when we talk about mixing two substances, or we are talking about making solutions. When we are talking about making solutions, we have solute and solvent that makes up the solution. Now in this solution, if I want to know the amount of solute present or solvent present, I will have to calculate the concentration of that particular solution. Okay, and there are different concentration terms. Like if I say, for example, if I say I have a salt solution. Now in that salt solution, if it is too salty to taste, we will say the concentration of salt is high. If it is less, if it is not as salty, we can say the concentration of salt is less, right? So concentration means the amount of solute in a particular solution. Okay, so let's start. Now the concentration solution can be expressed in different ways. Now that can be dependent upon temperature and can also be independent of temperature. For that you need to understand that what is the solution made of. We are going to take the solution's volume, and volume gets affected by the temperature. That's why wherever, in whichever concentration term you have volume included, that is going to be temperature dependent. Okay, and the one which has mass like grams or kg, both solute as well as the solvent are expressed in the terms of grams or kgs, that means its mass, then it will be independent of temperature. ऐसे एग्जाम्पल से आप समझ सकते हैं, जैसे मैंने एक कंटेनर के अंदर वाटर रखा हुआ है, and if I increase the temperature of that container, what will happen? Of course, the volume is going to be affected. A mass of anything does not change on increasing temperature. Now, amongst these, molarity, normality, formality, percentage calculation, ppm, ppb, all these come under the concentration terms which are temperature dependent. Now in percentage calculation also, when you have weight by volume or volume by volume percentage, only then it will come in temperature dependent. If it is weight by weight percentage, then it will come in not dependent. Okay, so temperature dependent and temperature independent terms. Okay, so molarity, of course इससे आप ये समझ ही गए होंगे कि molarity, normality, formality, all these include volume. So molarity, normality, formality. Formality is exactly like molarity, just the difference is this is particularly for ionic compounds. Then percentage calculation, it will be either weight by volume percentage or volume by volume percentage. Then ppm and ppb. Even ppm, ppb, if there is volume calculation, only then it comes over here. Now this side you have molality. That means molality does not include volume. Mole fraction, mass fraction, percentage calculation, which is weight by weight percentage categories. Alright. Now let's understand all of them one by one, including all the numericals. Let's start with the first concentration term, that is molarity. Now, what is molarity? Now, I told you this is regarding all the solutions. So, if you have a solution and you want to know how much amount of moles of the solute are dissolved in 1 liter of that solution. So, moles means N of solute. Now, N of solute can be written as mass of solute upon molar mass of solute. W is any mass, given mass or any mass or unknown mass. Capital M is the known mass. ये आप mole concept में भी already सीख चुके हैं. Capital M, which is the molar mass of the solute. Now this can also be written as N. Now number of moles of solute dissolved in 1 liter of the solution. That means volume of the solution should be volume of solute or mass of solute plus volume of solvent. Okay. So its formula will be, now this is given by capital M. Capital M equals to, now this capital M and this capital M is different. So I can write capital M, that is molar mass or molecular mass. So here we will write molarity equals to, so it can be written like this, N upon V. If volume is in ml, then multiply this with 1000. You are basically dividing ml by 1000 to get it into liters. Okay. Or the same thing can also be written as, N को हम expand कर सकते हैं, W upon M into 1000 upon V of the solution. This is of solute and this is of the solution. Alright. Now this is expressed in mole per liter because you have mole above and liter below. So this is mole per liter. Alright. Or over here mole per ml. So as you can see this question over here, 149 grams of potassium chloride is dissolved in 10 liter of an aqueous solution. Determine the molarity of the solution. So we'll simply start by moles, finding out the moles of the solute. Now what do we have is so we can find out moles of KCl by taking the weight of KCl given in the question, dividing it by the molecular mass of KCl. Molecular mass of KCl is K is 39 and Cl is 35.5. So it will be 74.5 the molecular mass. And in the question the weight is given as 149 gram. 149 grams upon 74.5 grams. So that's your mole, which is equal to 2. Now molarity will be moles upon the volume of solution. How much volume is given? 10 liters. So it will be 2 upon 10 liters, simply 0.2 m. So this is the molarity of the solution. We'll take more examples. Now one more thing, all these concentration terms are also interrelated. So if one is given, you can find the other also. We'll do that as well. Molarity is the number of moles of solute dissolved in 1000 grams or 1 kg of solvent. So both solute as well as the solvent are expressed in grams over here. Okay, so you have been given weights. So here you have moles of solute in 1000 grams of solvent or 1 kg of solvent. Earlier it was solution, this time it is only the solvent. So it's a big difference. Here it is solvent. There in molarity it was divided, the number of moles of solute was divided by the volume of the solution. Here it is solvent. Now again 1 kg is written. If it was in grams, you would have multiplied the whole thing by 1000. It's the mass of the solvent. Mass of solvent in grams. Let's take a numerical. 225 grams of an aqueous solution contains 5 grams of urea. What is the concentration of the solution in terms of molarity? Now, what are the given things? Mass of urea is given, that's 5 grams. Molecular mass is 60. How do you find out that? Urea ka formula is NH2CONH2. So you can find out the molecular mass from there. Now the given mass in the question is 225 gram of the solution. So solvent ka mass kya hoga? Urea ka mass subtract karna hai usme se. 225 minus 5, which will be 220 grams of the solvent. Now let's find out, put everything into the formula. Number of moles of solute will be, or urea will be 5 upon 60. And molarity will be, you can directly put it into the formula like this, 5 by 60, or solve it over there. Now because it's given in grams, so we're writing grams and 220. Now it will be 50, 6 22s are 132, that will be 0.378. Now over here, because it's molarity, it's given by small m. And also unit of molarity will be mole per kg. Now let's do another type of question. I told you that these can be correlated also. So you have a question right now over here. Calculate the molarity m of 3m solution of NaCl whose density is 1.25 gram per ml. Now over here you are given with density also. So how will you use density? Molarity given is 3m and molarity kya hoti hai? N upon V. And if I expand this, it will be W upon M into V. And above will be 1000, which is equals to 3m, right? Now, if I have to find out mass of NaCl in 1 liter of solution, then it will be molarity into the molecular mass, the molar mass of sodium chloride. You can say molecular mass also. So that will be 3 into 58.5, 175.5 grams. Okay, so this is NaCl ka mass. Now let's find out the mass of that 1 liter solution, because we need to find out ultimately molarity. अब mass कैसे मिलेगा? आपके पास density है, you can use that. Density is mass upon volume. You have density, so you can use to find out the mass by taking mass equals to D into V, that is density into volume. 1.25 into 1000, it will be 1250 grams. So there you have mass of solution. Now you have mass of solution, you have mass of solute also. So just subtract these two, you will get mass of solvent, and then we can put it into the formula of molarity. Mass of solvent will be (1250 minus 175.5, 1074.5 gram, which is also 1.074 kg. Okay, if I convert it into kg. So now molarity becomes, where is the mole of, now let's also have, see, if you don't want to find out the moles, you can put exactly the mass of this solute upon taking the molar mass of this substance. So the mass is 175.5 upon 58.5 gram into volume into the mass of solvent, that is 1.0745 kg. And is anything else left? I don't think so. Yes, that's it. So finally this is the molarity of the solution. Now we're done with molarity. Now the third one is normality. Now what is normality? Normality is a bit different. Over here we do not take moles but we take gram equivalents. Now what are gram equivalents? For example, you have an equation, a reaction of this type. Now if I take the moles, these coefficients are nothing but they will also show us the mole ratio of all these or moles of these particular reactants as well as products. And they are not even equal. When we balance out an equation, the moles are not equal to each other. They only help in balancing the number of atoms both the sides so that the total number of atoms both the sides are equal. But these moles will not be equal. Okay. But equivalence, when I talk about equivalents are always same for reactant as well as product. So if I say equivalence of A, then it will be equal to equivalent of B. It will also be equals to equivalent of C. It will be also equal to equivalent of D. For most calculations, this is the easiest way because we can equate two entities easily. Now what is equivalent? One equivalent of this will react with a fixed or it will displace the fixed quantity or equivalent of the other one. Let me take H2SO4 plus NaOH. Now over here this H2SO4 is going to release 2H plus and this will have 1 OH minus. Now these OH minus will be replacing these H2 plus, these H pluses. Now how many OH minus will be required for it? There will be 2 OH minus required. Now these two are going to be equal. That means the equivalence of these two are going to be equal. The equal amount of NaOH will displace equal amount of H plus from H2SO4. We will also learn about principle of equivalence and we will also take up more numericals based on that in another video. Now, so like we have molarity, number of moles dissolved in volume of solution. Here we have number of gram equivalents. Number of gram equivalents of solute dissolved in 1 liter of solution. Okay, so this is normality, which is denoted by a capital N. Okay. Now this number of gram equivalents, how to find them numerically? Number of gram equivalents, like number of moles are equal to mass upon molar mass. So number of mass upon equivalent mass. Now again, what is equivalent mass? I told you it is the fixed amount of mass which is displaced by the other equivalent. Okay, so equivalent mass क्या हो जाएगा? Equivalent mass is molar mass divided by N factor. Now N factor can be found out by various ways. We will discuss that as well. Now this can be also called as V factor, that means Valency factor, or Z factor, just Z, because sometimes it is the charge also. Okay, so it can be N factor or Valency factor or Z factor. If I put the whole thing into one formula, it will look like this. W upon equivalent mass is M upon N factor. So if I write it like this, M upon N, this will go upwards and it will be W into N, M into volume of the solution. If it is in mLs, then over here we will write 1000. Now can you recall molarity formula? Molarity formula was excluding N, the rest everything was same. W by M into V. So normality is also equals to molarity into N factor. This is an important formula. So here you can correlate both molarity as well as normality. Molarity के साथ n factor multiply कर दो, you will get normality. So this is the expanded version and this is the shortest one. Okay. Now we are going to learn how to find out n factor for any compound or a reaction. N factor जो है हर केस में अलग अलग होता है. If you have an acid, if you have a base, if you have a salt, or if you have a reaction, we are going to divide it into 4 categories. For acids, it's the basicity. For bases, it's the acidity of that base. If it is a salt, then it's the highest charge on either cation or anion. If it's a redox reaction, then n factor will be equal to the number of electrons gained or lost. Let's find out. First, for acids. Now for acids, it's the basicity of that acid. Basicity of acid. Example, you have HCl. Now it releases only one H plus ion. So it's a monobasic acid. So its basicity is 1. So when you have to find out equivalent mass of HCl, it will be molecular mass of HCl upon n factor of HCl. So equivalent mass of HCl will be, molecular mass क्या हो जाएगा? 1 plus 35.5, 36.5 divided by n factor, which is 1. So equivalent mass as well as molecular mass for HCl is same. Now if I take H2SO4, in H2SO4 there are 2 H pluses released. So basicity of H2SO4 is 2 because 2 H plus are released. So iska molecular mass upon n factor will be, molecular mass is 98, basicity is 2. So equivalent mass of H2SO4 is 49. Okay, you will not take 98 but 49. Now H3PO4 or H3PO3. In H3PO3, the structure is like this. In H3PO4, the structure is like this. The hydrogen that is attached or that is bonded to the oxygen is the one which is acidic hydrogen or the one which can be released as H plus, the protonic one. Okay, this one cannot, because out of phosphorus and oxygen, oxygen is more electronegative. Electronegative मतलब अपनी तरफ electrons it can pull or it can withdraw electrons towards itself. If it pulls electrons towards itself, H will be removed as H plus. And how many hydrogens in this structure are attached with oxygen? Only 2. This one and this one. The other hydrogen is directly attached to phosphorus. So I will have 2H plus releasing, and in this case, because we can see 3 hydrogens are directly attached to the oxygen, the more electronegative atom. So 3 H's can be released. Hence, basicity in H3PO4 will be 3 and over here it will be 2. So n factor for H3PO4 is 3, n factor for H3PO3 is 2. Now similarly for bases. For bases, it will be the acidity of those bases. If I have monobasic acid, of course, the n factor will be 1 because it can release only 1 OH minus. If it is diacidic, then the n factor will be 2. ALOH thrice 3. Okay, that's how you get the acidity of bases. Third is salt. Salt में, for example, I have calcium phosphate. Now if I take the cation, on the cation Ca, there will be, on each cation, there will be 2 plus charge. And there are how many total calcium ions? 3 calcium ions. So total charge on calcium will be 2. I am talking about 3 calcium ions. It will be 2 into 3. Because 2, 1 calcium पे और 3 calcium ions है. So total charge will be 6. So N factor for this salt will be 6. Now if there is no salt and you just have one element like oxygen, over here there is no charge also. So its valency itself becomes the N factor. For example, equivalent mass of oxygen if I have to find out, then it will be 16 जो oxygen का mass है divided by उसकी valency, then it will be 8. Now H2O2. In H2O2 also, because we get the ion as O2 2 minus, so there will be 2 H pluses. So over here also the valency factor will be 2. Now again coming back to the salts. Now this was a simple salt. If I have a complex salt, then a salt like double salt, like Mohr salt. Now in such a case, just calculate the total positive charges or the total negative charges. अब Fe, इसमें क्या क्या positive charges होंगे? Now there's 2 plus on Fe. There are 2 NH4. Each NH4 will be 1 plus. So 2 into 1. Total positive charge will be 4. So N factor of Mohr salt over here is 4. But if it is reacting with something, then it will change. But only for the salt, it is like this. You have to calculate. Just count the total positive charge or total negative charge for any salt. Now the last one is N factor for redox reactions. Now these are a few cases that you can write down now because these are going to be helpful. Like in all the redox reactions, it's going to be the same thing. For example, you have Mno4 minus going from Mno4 minus to Mn2 plus. I'll just write down all the different cases. This is an acidic medium. So if in the question, it's written already, FeSO4 or more salt, it is titrated against potassium permanganate in acidic medium. So over there, N factor has to be whatever I am going to tell you now. Mno4 minus to MnO2. This is basic medium or alkaline medium. Lastly, we have Mno4 minus going to MnO2, MnO4, 2 minus form. Okay, this one is also basic medium. Now this can be neutral also. It is slightly neutral. It is either neutral or slightly alkaline. Either slightly acidic or slightly alkaline. Now just check the number of electrons being lost or gained. Now firstly, if you have to find out the oxidation number of a particular element, how will you do that? Now we have to find the oxidation state on Mn, because for oxygen and hydrogen, you should remember for hydrogen the oxidation state is +1, provided it is not hydride, it is only proton or hydrogen. Okay, if it is hydride, then the charge will be 1 minus. And for oxygen, the charge will be -2. Cases wherein you have H2O2 or OF2, over there the oxidation state of oxygen changes. Here, but usually it will be -2 for oxygen and for hydrogen it will be +1 if it is not hydride. Okay, so Mn का X ले लो, oxidation state, plus 4 into एक oxygen पे कितना charge होता है? -2. And total charge will be -1. तो X क्या हो जाएगा? -1. 4 into 2 is -8. तो इधर आके हो जाएगा +8. So 7. So over here you have +7 charge and here you have 2 plus charge. So +7 से 2 plus जाने के लिए what will happen? There will be, if it is +7, there will be minus 5 electrons or just 5 electrons added to Mn7 plus. Only then it will turn Mn2 plus. So because there is addition of electrons and addition of electron here, so it is undergoing reduction. So in acidic medium, there will be reduction of Mno4 minus to Mn2 plus, and because it is gaining 5 electrons, so N factor over here will be 5. Now in some cases, if you have the whole thing, जैसे यहाँ पे KMnO4 है, so you can directly have 5 electrons and it will be 5 N factor. But over there, if you had barium manganate, then if one MnO4 gain 5 electrons, then 2 MnO4 will gain 10 electrons. So over there, the N factor will be 10. So this is something you have to keep in mind. Next, Mno4 minus से MnO2. Again, Mn पे plus 7 charge and MnO2 पे, Mn पे क्या charge होगा? Because oxygen is minus 2 and minus 2 into 2 is minus 4. So this has to be plus 4 because the overall charge on this compound is 0. How? Mnx plus 2 into minus 2. There is no charge, so 0. So x will be plus 4. So from plus 7 to plus 4, what will happen? Now this happens again. See, the gain of electrons occurs mostly in acidic medium. So it is slightly acidic or neutral. So there will be gain of 3 electrons. So N factor will be 3. In the last one, because over here you can see it is going from plus 7 to, now again find out the charge on Mn. It will be x minus 4 to the 8 equals to 2 minus, it's a negative charge. If it is minus 2, then x will go, so the x will be minus 2 plus 8, it will be 6, and that to plus 6. So here plus 7 से plus 6 जा रहा है, so क्या होगा? There will be only gain of 1 electron, and gain of 1 electron will make the N factor over here 1. So summing up all of these, when you have acidic medium and MnO4 minus going to Mn2 plus form, N factor will be 5 provided इसके साथ cation जो होगा उसके ऊपर 1 charge है, because over here you have minus 1. If you had BaMnO4 whole twice, then the N factor would be 10, because then there will be 2 MnO4 minus and 1 MnO4 gains 5 electrons. MnO4 minus plus 7 से plus 4 जा रहा है, where you have MnO2. Again, this is either neutral or slightly alkaline. So again here there will be 3 electrons being gained. Then you have basic medium where you have MnO4 minus going to MnO4 2 minus. Over there you have only 1 electron being gained. Okay, plus 7 say plus 6. You just have to find out the oxidation states. Cr3 plus. Now balance it out. Here you have 2 chromium. So here also you will be having 2 chromium ions. Now again this is also in acidic medium. So chromium के ऊपर charge ढूंढो 2x, because we do not know what is the charge of chromium. 2x plus 7 into minus 2 equals to total charge of the compound or ion. So it will be 2x minus 14 equals to minus 2, x minus 7 equals to minus 1, x equals to minus 1 plus 7, which is plus 6. So plus 6 से plus 3 जा रहा है. Plus 6 से plus 3 कब होगा? When there is gain of 3 electrons. You must have seen in acidic mediums the gain of electron is comparatively more to that of basic medium. Okay? So जहाँ पे भी basic medium होगा वहाँ पे बहुत less electron gain होगा. So plus 6 से plus 3 electrons are being gained, but that is per chromium atom. So for 2 chromium atom it will be again 6 electrons being gained. Okay? So N is, or NF, you can say N factor is 6. Now let's do a numerical based on normality. So here's the question. calculate the molarity and normality of 12.6 gram of the acid in 500 ml of the solution. Now firstly what we can do is we can find out the molar mass of the acid. Now here you are given with oxalic acid. Oxalic acid होता है COOH whole twice. तो mass क्या होगा? 12 plus 16 plus 16 plus 1 into 2. So that will be, it's given in the solution as dot 2H2O. So plus 36, 2 into 8, 126 grams. Okay. So that's the molar mass of the acid. Now first, let's find out equivalent mass of oxalic acid solution. So equivalent mass क्या हो जाएगा? Equivalent mass equals to, because this is oxalic acid which has 2 COOH groups and each COOH group will release 1 H plus. So there will be 2 H plus release. So basicity is 2. So N factor is also 2. Molar mass upon N factor which is 2. 63 grams as equivalent mass. So simply put all the values into the formula for molarity. W by M 126 upon capital M 12.6 upon 126 into 1000 and it is in 500 ml of the solution. So because it was given in ml, so we have made it 0 to M. Similarly, if I have to find normality now, what I can do is N equals to M into N factor. N factor is 2, so it will be 0.02 into 2, which is 0.04 N. So this is your molarity, this is normality. Very easy question. Okay, so when there is either dilution of a solution, then you can use a formula which is dilution equation. You call it as, now this is for molarity I am talking about. M1V1 equals to M2V2. Okay. For example, one solution is diluted, so there will be some amount of water or solvent added to it. So the solution's volume will change. So if the solution's volume is changing, molarity will also, or the concentration you can say, will also change because it is getting diluted. So in that case, you will have new molarity and new volume. You can use this formula. Similarly, in normality also, we can do the same thing. Like you have 2 to 3 solutions being mixed, then you will have to find out the concentration of final solution. In that case, we can do, like if you have 2 to 3 solutions being added, N1V1 plus N2V2 plus whatever amount, like whatever, if there's one more solution, then add that as well. Then N final, V final of the whole solution. Of the new solution, what will be the concentration? That will be N final, V final. For example, you have a question, 1 liter of 0.1 m NaOH, 1 liter of 0.2 m KOH and 2 liter of 0.05 m BaOH twice are mixed together. What is the final concentration of the solution? Now everything is directly given. Just multiply the concentration with the volume and you will get the final volume and final concentration of the solution. Next is mole fraction.